So as a neuroscientist, I feel the need to tell you that we've been largely overlooking about half the brain. The preeminent goal of neuroscience is to understand the neuron and how neurons communicate with one another, how they form circuits, and how those circuits lead to outputs, things like consciousness, thought, behavior. As a result, the cell that we've studied in neuroscience is the neuron. And obviously, I'm not going to say to throw those out entirely, but there's more to the brain than just neurons. Astrocytes, cells named after stars, make up about 50% of the brain or more, and they've been largely overlooked, particularly with regards to behavior. The main functions of neurons, or of astrocytes, that we know of are more that they're the glue that holds the brain together. They feed the neurons, but they also have instructive, active roles in the chitter-chatter going on between neurons. So say you're a neuron and you're at a party and you're chatting with another neuron, and a guy comes in and butts into the conversation. He can either disrupt that conversation, take it to the next level, or move it in a completely different direction. So that guy's an astrocyte, and back in the brain, they're having roles in that conversation. Now, most of our treatments for brain diseases have largely failed. As such, we don't have successful treatments for things like Alzheimer's disease or brain aging. But most of these treatments have targeted neurons and largely overlooked the other cells in the brain. My work is focused on behaviors and how astrocytes affect these behaviors that are negatively affected in brain aging and Alzheimer's disease, so we can understand their function and potentially develop novel therapeutics. Because maybe the key to solving brain diseases and brain aging is not in the neurons, it's in the stars. Thank you.